Hello, and welcome to Night Lectures. I am very glad you're here. Before we begin, tell me, where are you spending this evening? Perhaps you're relaxing in a quiet bedroom, or curled up on a comfortable sofa with a cup of hot tea, or perhaps you're traveling peacefully on a train. Wherever you are, I hope you feel calm, safe, and ready to gently sink into a moment of reflection. If you enjoy these peaceful stories and want to hear more, please support the channel by liking and subscribing. Your small gesture helps preserve this magical space. And to those who are already part of our little sleepy community, thank you from the bottom of my heart. Your support means more to us than you can imagine. So, let's begin our journey. In a small town surrounded by green hills and quiet streams, lived a man named Jack. He wasn't the most remarkable person, but he was often seen alone, sitting on an old wooden bench in the park. Sometimes he just gazed at the clouds, and other times he would ask himself questions that, as he thought, no one could answer. Why is the sky blue? That was the first question Jack asked himself one summer day while sitting on that very bench. He couldn't quite understand why, even though the sun was shining brightly, the sky appeared so calm and blue. He tried to find the answer in books, but they only mentioned atmospheric light scattering. Jack couldn't accept this because he wanted to find something deeper in the answer. He knew that sometimes the world around us is far more complex than it seems at first glance. And so, sitting on the bench, he thought to himself, if the sky can be explained simply, what about the other mysteries of the world? Then his thoughts drifted further, and he remembered all his old questions. He wondered why, when he threw a stone into the water, the ripples spread out, but never came back to the point where the stone had fallen. Why does light shine but can't be touched? How can something be in one place and another at the same time? And in the end, what lies behind all these mysteries? Some might say that there are answers to all these questions. But Jack understood. The more he learned, the more questions arose, and the more mysterious the world around him became. What if the answer to all these questions is hidden in the tiniest particles? Jack thought. He remembered hearing about quantum physics once. It was something unclear, almost magical, and most of all, very mysterious. It seemed to explain not what we see every day, but something hidden from our eyes. And so that summer night, sitting on the bench, Jack decided he would try to understand it. Not to become a scientist, but simply to understand for himself what this strange, mysterious science was all about. What, in fact, made this world so mysterious? He decided to embark on a journey, but not through countries or continents. His path would be much more surprising and mysterious, a journey within himself into the world of quantum physics. Jack didn't know that his journey would be like a magical adventure where every step would uncover new secrets, and the sky, which he once thought was simply blue, would become even more mysterious. He just wanted to understand what made this world so fascinating, even if everything seemed simple. And so he took his first step, and at that very moment, his meeting with the most extraordinary, wondrous, and unfathomable world began. The world of quantum physics. Jack sat back, allowing the cool evening air to brush against his face as he let his thoughts drift. He wondered, if everything in the world is governed by something, some rules or laws, then why don't we see them? After all, life feels so ordinary. The sun rises every day, the leaves rustle in the wind, and the moon glows softly in the night sky. So, how do we even begin to explain all of this? He decided to take a step back, to think about the world as it was before all the mysteries of quantum physics came into play. The world he saw around him, the world he knew so well, a world where things happened predictably and everything made sense. He thought of the basic rules that seemed to govern everyday life. For example, why did a ball fall to the ground when he dropped it? Or why was it so hard to push a heavy box across the floor, but much easier to push a small one? There had to be simple explanations, right? He began to break down his thoughts into more manageable pieces, just as he would solve a puzzle. The first rule Jack remembered was gravity, the invisible force that kept him grounded on Earth. Gravity was something he felt every single day. He had never seen it, but he knew it was there, pulling everything toward the center of the planet. It was gravity that made the apple fall from the tree, that kept the oceans in place, and that allowed him to stand without floating away. He smiled as he thought about the famous story of Sir Isaac Newton, who one day sat under a tree and watched an apple fall. That moment led him to realize that there must be a force acting on the apple, pulling it down to the ground. And just like that, gravity was born in our minds. Newton's law of gravity helped explain why things fell, why the planets orbited the sun, and why people stayed firmly planted on the earth. Simple enough, Jack thought. But what about the force I feel when I push a car or when I run? That brought him to another fundamental idea. Force. It was force that caused things to move. If he wanted to get his car rolling, he needed to apply a force to it. The same went for anything, whether it was a bicycle, a chair, or even his own body. The more force he applied, the more movement he created. But force wasn't just about pushing things. There was another part to it, something that seemed to balance out everything: resistance. If he were to push his car on a flat road, it might move easily. But if the road were muddy, the car would become harder to move. The mud acted like a force that resisted his push. Jack remembered his high school physics teacher explaining the concept of inertia, an object's tendency to keep doing what it's doing unless something else forces it to change. So, if he was driving a car and suddenly slammed on the brakes, the car would continue moving forward until the brakes acted to slow it down. That was inertia in action. It was the reason why he had to be careful when driving, and why seat belts were so important. They helped stop the body from continuing to move forward when the car suddenly stopped. Thinking about inertia reminded Jack of another law, this one from Newton too, the law of motion. It explained that the harder you push something, the faster it will move. The same principle worked whether he was pushing a grocery cart or throwing a ball. The stronger the force, the quicker the movement, and the heavier the object, the more force it would take to move it. He could push a soccer ball easily, but trying to push a car would be a whole different story. As Jack thought about all these rules, he realized that physics, the science that governed these forces, was all about explaining the relationships between things, the forces, motions, and reactions that shaped his world. He could see how everything fit together. The apple fell because gravity pulled it down. He could push something because he applied force. and the resistance of the ground or air slowed him down. The laws of motion showed him how objects moved or stayed still, and inertia helped him understand why objects resisted change. Jack stretched his arms and relaxed into the bench. He could feel how all these forces played out every day. The world seemed predictable and logical when you looked at it through the lens of these laws. But that didn't mean everything was always easy to understand. Sometimes there were moments when things just didn't make sense, no matter how much he thought about them. But for now, Jack was happy. He had a solid understanding of the world as he knew it, the world where things followed predictable patterns. If he dropped something, it would fall. If he pushed something, it would move. If he jumped, he would come back down. The rules of physics, simple as they were, made life more manageable. And for Jack, that was enough. He knew that even though some things were complicated, like how the seasons changed or how the stars seemed to move across the sky, at least there was a sense of order in it all, a quiet, dependable order that existed in the universe around him. As he sat there, deep in thought, Jack felt a sense of calm. For now, he was content to think of the world as a place where gravity held things down, inertia kept things moving, and force pushed and pulled everything in its path. It made him feel connected to the world in a way that felt reassuring. But even as he sat there, Jack knew that somewhere, hidden deep beneath all of these comforting rules, there were mysteries waiting to be uncovered. What if there were parts of the world that didn't follow these simple laws? What if, beneath the calm surface of everyday life, there was something much stranger and more unpredictable, something that defied explanation? As the sun began to set and the evening stars started to twinkle, Jack couldn't help but feel a sense of wonder. The world was so beautiful, so orderly, yet so full of unanswered questions. He couldn't wait to learn more about the mysteries that lay just beyond the rules of everyday physics, and he felt in his heart that his journey into the world of quantum physics was just beginning. Jack leaned back on the park bench, the evening sky darkening as the stars began to twinkle, casting a soft glow over the quiet streets of his small town. He'd spent hours thinking about the rules of physics, about gravity, force, motion, and inertia. Everything in the world seemed to follow certain patterns, like an intricate dance. But something still bothered him. Something about the world didn't quite add up. His mind wandered back to something that had always puzzled him, something he had never been able to explain. He thought about the small things that didn't make sense, the oddities that lurked beneath the surface of everyday life, things that seemed to break the neat, orderly rules he had just come to understand. He remembered the first time he dropped a coin into a clear glass of water. The coin sank to the bottom as expected, but as it did, something strange happened. The water, which had been perfectly still before, began to ripple in all directions. The ripples spread outward from the point where the coin hit the water, but they didn't stop. They kept spreading, ever widening, until they became tiny, barely visible waves along the surface. Jack watched in awe, wondering why the ripples behaved this way. He could easily understand the coin sinking. That was gravity at work. But why did the ripples continue forever, fading into nothingness? And how did they start in the first place? Jack's curiosity piqued and he thought back to something he'd read about light. He'd always assumed that light worked like a tiny stream of particles, traveling in straight lines, illuminating everything in its path. But what about the way light bends around corners, or how it can pass through thin slits and create strange patterns? It didn't behave the way he thought it should. Sometimes light seemed to behave as if it were both a wave and a particle at the same time. But how could that be? How could something be two completely different things at once? Suddenly, his mind flashed to another curious event. He remembered watching a documentary about particles, where the narrator described an experiment in which a beam of light was directed through a set of two narrow slits. As the light passed through, it didn't just create two patterns on the wall like expected. Instead, the light seemed to create an entire range of patterns, as though it was simultaneously behaving like a wave. The experiment seemed almost magical. What was going on here? As he sat there, Jack couldn't shake the feeling that the world he knew, the one governed by the laws of physics, wasn't the entire story. There was something more, something hidden beneath the surface. The deeper he thought about it, the more it became clear that the world wasn't as simple as it seemed. Even the most basic things, like the way light behaved or how objects moved, didn't always follow predictable patterns. The more Jack thought about it, the more questions popped into his mind. He had learned that things fell to the ground because of gravity, and that forces caused objects to move. But what about the strange behavior of tiny particles? What about the fact that particles could be in more than one place at the same time, or could appear to know things about each other, even if they were miles apart? Was this still part of the same predictable world? Or was there another set of rules at play, rules that didn't follow the logic he had come to understand? Jack stood up and paced around the park, his thoughts swirling. He remembered reading about a strange phenomenon called quantum entanglement. In this phenomenon, two particles could become entangled, meaning that their properties became linked in such a way that the state of one particle immediately influenced the state of the other, no matter how far apart they were. In other words, if one particle was spun in a certain direction, the other would instantly be spun in the opposite direction, even if one particle was on Earth and the other was light years away. They would still be linked in this strange way. How could that be? It didn't seem possible, and yet it was happening. Jack paused, his mind racing. He thought about the implications of quantum entanglement. It felt as though the universe was playing tricks on him. Things weren't supposed to be able to influence each other like that, especially not at such vast distances. The simple laws of cause and effect seemed to be turning upside down. But Jack also remembered something important. Even though quantum entanglement didn't seem to make sense, scientists had observed it and measured it repeatedly. It was a phenomenon that couldn't be explained by the simple laws of physics he had come to know. And it wasn't the only strange thing he had encountered. There were also experiments where particles behaved unpredictably, even when scientists tried to measure them. It was as though the very act of observation changed the way things behaved. How could something be so random, so unpredictable? It was as though the universe had a secret, one that it only revealed under certain circumstances. Jack couldn't ignore it anymore. There was a whole part of reality that he couldn't explain, a hidden layer of the universe that didn't obey the rules of everyday physics. The more he thought about it, the more he realized that perhaps the world he lived in was only part of the story. Beneath the surface, there were layers upon layers of mysteries waiting to be uncovered. He sat back down on the bench, looking up at the sky, trying to wrap his mind around the strange things he had just learned. The stars, the moon, the planets. They all followed the predictable rules of gravity. But what about the particles, the tiny building blocks that made up everything? Why didn't they follow the same rules? It was as if the universe itself had two faces, one that was simple and easy to understand, and another that was baffling, full of puzzles and riddles. Jack took a deep breath and smiled to himself. It was frustrating, yes, but it was also exciting. The world wasn't as simple as he had thought, and that, in a strange way, made it more beautiful. There was so much more to explore, so much more to understand. The mysteries were only just beginning to unfold. As he sat there, Jack realized that the universe wasn't trying to confuse him. It was simply showing him a side of itself that he had never seen before, a side where logic didn't always apply, where strange things happened that couldn't be explained by the old rules. And perhaps, just perhaps, it was this very mystery that made the world so fascinating. There was always more to discover, always more questions to ask. As the stars shone brightly overhead, Jack felt a sense of calm wash over him. Yes, the world was full of mysteries, but that was what made it worth exploring. And as he looked up at the night sky, he knew that his journey into understanding would continue. There was so much more to learn, and that thought filled him with excitement. Jack leaned back, the cool breeze carrying the faint scent of flowers through the air. It was one of those quiet, peaceful evenings, the kind that made it easy to think clearly. He had spent the last few days thinking about the strange behavior of particles, about light and matter, and how things didn't always make sense. But today, something else caught his attention, a mysterious idea that seemed to explain why the world felt so unpredictable. He'd heard about it before, the principle of uncertainty, a fundamental concept in quantum physics that suggested something very strange. You could never know everything about a particle. There was always a limit to how precisely you could measure certain things, and the more you knew about one thing, the less you could know about another. It wasn't like the rules Jack was used to. In the world of everyday physics, if he knew where something was, he could predict its movement. But in the world of quantum physics, the idea of certainty seemed to vanish. Jack's curiosity was piqued. What did this principle really mean? And how did it change everything he thought he knew about the universe? He closed his eyes for a moment, trying to think of an analogy that would make sense of this strange idea. He remembered a moment from his childhood when he tried to catch fireflies. He would run around the yard at night with a jar in his hand, chasing after the glowing insects. Sometimes he could get close enough to see the firefly clearly, but the instant he tried to catch it, it darted off somewhere else. Even when he was sure he knew where it was, it always seemed to move in unexpected directions. Jack smiled, thinking how frustrating that had been, and how perfectly it illustrated what he was beginning to understand about quantum particles. It was like trying to catch a firefly and measure exactly where it was and how fast it was flying at the same time. No matter how hard you tried, you couldn't do both. If you focused on one, the other became uncertain. He began to think about the key figure behind the principle of uncertainty. Werner Heisenberg, the German physicist who had first formulated it in 1927. Heisenberg had shown that there were two properties of a particle, like its position and momentum, which is its mass times velocity, that could never both be known with perfect precision at the same time. The more precisely you measured one, the less precisely you could know the other. Jack thought about this for a moment. It was like a balancing act. Imagine trying to measure the position of a bouncing ball with perfect accuracy. To get the exact location of the ball at any moment, you'd have to focus entirely on it, but in doing so, you'd lose track of how fast it was moving or in what direction. On the other hand, if you focused on how fast the ball was moving, you'd lose the exact position. The principle of uncertainty told Jack that this wasn't just a limitation of technology or the tools we had to measure things. It was a fundamental feature of the universe. It wasn't that we were missing something. It was that nature itself prevented us from knowing everything about a particle at once. Jack found that fascinating. The idea that the very nature of reality had built-in limits on how much we could know made him feel both awe and a bit of frustration. He had always assumed that, given enough time and the right tools, he could understand everything. But this principle seemed to suggest that there would always be some level of mystery, a limit to knowledge. No matter how sophisticated its measurements were, the truth would always remain just beyond his reach. He thought about it more. Let's say he was standing on the edge of a lake and throwing stones into it. If he wanted to know exactly where each stone landed, he'd have to carefully observe each one. But as he focused on one stone's location, he couldn't track its speed, its path, or the way it moved through the air. The moment he measured one thing, he lost track of the other. And this wasn't just about stones or fireflies. This was the way particles behaved at the most fundamental level. Jack tried to grasp the broader implications of this principle. The uncertainty principle applied to particles that were so tiny, so small, that they behaved in ways that seemed completely counterintuitive. The principle didn't mean that scientists couldn't measure things accurately. They could. But it told them that there was always a trade-off between two things they couldn't measure simultaneously. And this trade-off wasn't just a minor inconvenience. It was a fundamental part of the nature of particles themselves. In some ways, the principle of uncertainty made the universe feel unpredictable. If you couldn't know both the position and momentum of a particle at the same time, how could you predict where it would go? It seemed like the universe was playing a game with no fixed rules, one where randomness and uncertainty were built right into the fabric of reality. But Jack also realized something else. The principle of uncertainty didn't mean that everything was chaotic or random. In fact, it was quite the opposite. The uncertainty was predictable. Even though Jack couldn't know both the position and momentum of a particle at once, he could still predict the probabilities of what might happen. For example, if he were to measure the position of a particle, he could predict the range of positions where it might be found but not the exact one. It was like trying to guess where the firefly would be. He might not know exactly, but he could still make an educated guess based on the patterns. This was the beauty of quantum physics. It didn't operate with absolute certainty, but it worked with probabilities. It allowed for a whole new way of understanding how the universe worked, one where uncertainty wasn't something to fear, but something to embrace. Instead of thinking that we could know everything about a particle, we learned to understand the range of possibilities that could happen. Jack leaned forward, his mind buzzing with all the possibilities. He thought about how Heisenberg's principle was so different from the simple physics he had learned before. In the world of everyday life, if you knew the position of something, you could calculate its future movement. But in the quantum world, the future of a particle wasn't determined with certainty. Instead, it was spread out, with different possibilities all existing at once. Only when you measured something did one possibility become real. Before that, the particle existed in a state of potential, a kind of quantum soup of possibilities. For Jack, this was both a beautiful and frustrating thought. The universe wasn't a neat, orderly machine, ticking away according to the laws of classical physics. It was messy and uncertain, full of possibilities and probabilities, where certainty could never fully exist. And yet, despite this uncertainty, the universe still operated according to predictable patterns, patterns that we could study and understand. Jack sat there, lost in thought. The principle of uncertainty had turned everything upside down for him. The world he thought he knew, the world where everything had a definite position and motion, was now a place where uncertainty was a key player. It was as if the universe was telling him that not everything could be known, that there was a mystery at the heart of reality that would forever be beyond his grasp. But in a way, Jack realized, that was the most exciting part. The uncertainty wasn't a flaw in the universe. It was an invitation to explore. There was always more to discover, always something new on the horizon. And the principle of uncertainty, strange as it was, only added to the beauty of the world, making it even more wondrous and full of mystery. As the evening sky deepened into night, Jack stood up from the bench and stretched. He felt a sense of peace, knowing that some things, even if they weren't fully understood, could still be embraced. The universe wasn't predictable in the way he had always imagined, but that only made it more incredible. There would always be mysteries to explore, and the uncertainty, far from being a burden, was a challenge to keep learning, to keep wondering. With a final look at the stars, Jack smiled. The world was vast, full of unknowns, and the principle of uncertainty was just one of the many puzzles that made it so fascinating. And he couldn't wait to keep unraveling them. The night had fallen deep, and Jack sat on the same park bench where he had spent so many evenings, lost in thought. The cool air wrapped around him like a blanket, and the quiet hum of the town seemed far away. Tonight, though, Jack's mind was far from peaceful. It was racing with a new question, one that had been bothering him for a while now. What exactly is light? He had learned about light in school, of course. It was the thing that allowed him to see the world, the thing that made everything visible. He knew light came in the form of waves, and he had heard that it was somehow tied to the idea of energy. But recently, Jack had come across something strange, something that made him reconsider everything he thought he knew about light. He had heard that light was not just a wave, but also a particle, something that didn't make sense at all. How could light be both a wave and a particle? It was a question that didn't quite fit with the tidy world of everyday physics that Jack had grown to understand. In the classical world, waves and particles were two different things. Waves were like the ripples on the surface of water, spreading out from their source, while particles were like tiny little balls, each with its own distinct identity. Waves and particles were opposites, right? So how could light be both at the same time? As Jack pondered the question, his thoughts drifted back to something he had learned about in his physics classes, the wave theory of light. This theory explained that light behaved like a wave, much like the ripples on a pond when you drop a stone into the water. These waves could spread out in all directions, and they carried energy as they moved through space. The idea of light as a wave made sense to Jack. After all, light could create patterns of interference when it passed through narrow slits, just like the way ripples from two stones dropped in the water could interact with each other. But then Jack remembered something even stranger. If light could behave like a wave, it could also behave like a particle. This concept came from the idea that light wasn't just a smooth wave, but also made up of discrete packets of energy called photons. A photon, Jack thought, was like a tiny particle that carried energy and could interact with matter, like when light knocked electrons off a metal surface in the famous photoelectric effect. The photoelectric effect was one of the key experiments that made scientists realize that light had a particle nature. When light of a certain frequency struck a metal surface, it caused the metal to eject electrons. The strange part was that only light above a certain frequency could cause this to happen. It wasn't enough for the light to simply be bright or intense. The frequency had to be right. This didn't make sense if light were just a wave. Waves could carry more or less energy depending on their amplitude, brightness. But they didn't seem to have a specific frequency that mattered in this way. The fact that the frequency was important meant that light had to behave like a particle, something with specific energy, not just a continuous wave. Jack felt his mind begin to spin. How could light be both a wave and a particle at the same time? It seemed impossible. But the more he thought about it, the more it seemed like the universe was playing a trick on him, pushing the limits of what he thought was possible. The answer, he realized, was in the very nature of quantum physics, the world of particles and energy that didn't follow the same rules as the world of everyday experience. Jack had heard scientists refer to this as wave-particle duality, the strange property of light and other particles that made them behave both like waves and particles depending on how they were observed. This wasn't just a quirky little detail. It was one of the most fundamental aspects of quantum mechanics. The idea that light could switch between being a wave and a particle, depending on the situation, was something that didn't fit into any of the neat boxes Jack had learned about in his previous studies of physics. Waves and particles were supposed to be separate concepts. But in the quantum world, that wasn't the case. To illustrate this further, Jack remembered another famous experiment, the double-slit experiment. In this experiment, light was shown through two narrow slits, and the pattern of light that emerged on the other side was recorded. When light was passed through the slits, it didn't just create two lines of light where the slits were. Instead, it created a pattern of interference, a series of alternating dark and light bands, like ripples from two stones dropped in water. This behavior suggested that light was behaving like a wave, spreading out and interfering with itself as it passed through the slits. But here's where it got even stranger. When scientists set up detectors to observe which slit the light passed through, the light behaved completely differently. Instead of creating an interference pattern, the light behaved like particles, creating two bright spots on the screen corresponding to the slits. It was as if the act of observing the light had forced it to choose whether it was a wave or a particle. In the absence of observation, it behaved like a wave, but when measured, it acted like a particle. Jack was fascinated. How could the very act of observation change how light behaved? This seemed to suggest that the universe itself was somehow fundamentally uncertain, that it could be in multiple states at once, until someone checked to see what was happening. This wasn't just a theoretical concept. It had been observed, measured, and proven through countless experiments. But the implications were enormous. He thought about how strange it was that light could switch between being a wave and a particle depending on the circumstances, and yet this was a property shared by all quantum objects, not just light, but also electrons, protons, and other subatomic particles. They too exhibited this wave-particle duality. Jack began to realize that quantum mechanics didn't just apply to light. It applied to everything at the tiniest level of reality. The world of quantum mechanics was full of paradoxes, things that didn't make sense from the perspective of classical physics. Particles could be in multiple places at once. They could interfere with themselves, and they could change behavior based on how they were observed. It was a world where the old rules of cause and effect didn't always apply. It was a world that was as strange as it was fascinating. But there was something beautiful about it, too. Jack felt a sense of awe as he thought about how light, something as familiar as the sunlight streaming through the trees, could hold such secrets. Light was both a wave and a particle, two things that seemed incompatible, yet somehow they existed together. And this duality was just the beginning of the mysteries that quantum physics had to offer. The more Jack learned, the more he realized that the universe didn't always behave in ways that were easy to understand. It was a place full of surprises, where the simple rules he had learned didn't always apply. And yet there was a strange kind of beauty in that. The world wasn't just a machine running according to fixed laws. It was something more mysterious, more fluid, and more complex. Jack smiled as he looked up at the stars. They twinkled in the vast expanse of the night sky, each one a tiny point of light in the darkness. He knew that light was more than just something he could see. It was a bridge to a whole new world, a world where particles could behave like waves, and waves could behave like particles. And that world, Jack thought, was as full of wonder as it was full of mystery. The night had deepened, and Jack found himself once again on his favorite park bench. The air was crisp, and the world around him seemed to be asleep, with only the occasional rustle of leaves and distant hum of the town filling the silence. He was still thinking about light, how it could behave both as a wave and a particle. But tonight, his thoughts were turning toward something even stranger, something that made the idea of light's dual nature seem almost ordinary. It was the concept of quantum superposition, and Jack was both fascinated and overwhelmed by it. He had first come across the term in a book on quantum mechanics, and ever since it had been gnawing at him. The idea that a quantum system could exist in multiple states at once was so far removed from anything Jack had ever experienced that it seemed almost absurd. How could something be in two places at once? How could an object be both here and there, both alive and dead, all at the same time? He had to admit, the more he thought about it, the more it seemed to stretch the limits of his imagination. Jack took a deep breath and tried to focus. To understand quantum superposition, he needed to take a step back and look at the foundations of quantum mechanics. He had learned that quantum systems, particles like electrons, photons, and atoms, didn't follow the neat, predictable rules of classical physics. Instead of existing in just one state, like a ball sitting still on the ground, quantum particles could exist in many different states simultaneously. He smiled as he remembered one of the simplest analogies he had read about. Imagine that he was standing at the edge of a cliff, deciding whether to jump or stay. In the classical world, he would either be standing on the edge or he would have jumped. But in the quantum world, things work differently. According to superposition, he could be both standing on the edge and jumping all at once. It was as if he were in two places at the same time, living in two different possibilities. Jack thought about how strange that was. In the world he was used to, things were either one thing or another. A coin was either heads or tails. A door was either open or closed. But in the quantum world, things could be in a combination of states, like a coin that was both heads and tails, spinning in the air, not yet decided. This was what quantum superposition was all about. The ability of a quantum system to exist in multiple states simultaneously. A particle could be in two different places at once, or it could have multiple energies or even multiple velocities. It was only when you measured the system, when you looked at it, that it collapsed into one definite state. Jack found himself marveling at the implications of this. The idea that a particle could be in several places at once, existing in a kind of haze of possibilities, seemed almost magical. It didn't fit with anything Jack had learned before, but this was the strange and paradoxical world of quantum mechanics, where the rules of everyday life no longer applied. To understand this better, Jack remembered a thought experiment called Schrödinger's cat. It was one of the most famous and bizarre thought experiments in the history of quantum mechanics. Schrödinger, a physicist, had proposed a scenario in which a cat was placed inside a box with a device that had a 50% chance of killing the cat, say by releasing poison gas, and a 50% chance of leaving the cat alive. According to quantum mechanics, until the box was opened and the cat was observed, the cat could be considered both alive and dead at the same time. A superposition of states. Jack paused to digest this idea. The very thought that a living creature could exist in two states simultaneously was both mind-boggling and, in a strange way, poetic. The universe, at its most fundamental level, wasn't just a place where things were alive or dead. here or there. It was a place of endless possibilities, where everything could exist in multiple forms until it was observed. This idea, though difficult to grasp, had profound consequences for the way scientists understood reality. It meant that, at the quantum level, the world didn't behave according to the deterministic rules Jack had always known. Instead of being bound by cause and effect, quantum particles existed in a cloud of probabilities, waiting to be defined only when measured. Jack thought about how strange this was. In his everyday life, when he watched the sun rise, he didn't wonder whether it would rise and not rise at the same time. When he dropped a stone, he didn't wonder if it would fall and not fall at the same time. The world felt predictable. It felt real. But in the quantum world, predictability was replaced by uncertainty. Things could be both one thing and another, both present and absent, both moving and still, depending on the observer. This brought him to another concept that was closely tied to quantum superposition: wave function collapse. Jack had read about it in his books and understood that it was an essential part of quantum mechanics. The wave function was a mathematical description of all the possible states a particle could be in. It represented the probabilities of where a particle might be, what energy it might have, or how fast it might be moving. Before a particle was measured, its wave function represented a cloud of possibilities, an infinite range of potential outcomes. But once the particle was measured, the wave function collapsed, and the particle was forced to choose one specific state. The act of measurement seemed to determine the outcome, collapsing the wave of probabilities into a single reality. Jack tried to visualize this. Imagine standing at the edge of a cliff, deciding whether to jump or not. Until you made the decision, you were both jumping and not jumping. But once you made the choice, once you observed yourself, the wave of possibilities collapsed, and you were either standing still or falling. The possibilities were not real until you measured them. This brought up a deeper question. What is the role of the observer in all of this? Why did the wave function collapse when it was measured? Why didn't the particle just stay in its state of superposition until it was forced to collapse? These were the kinds of questions that puzzled scientists for years. Jack remembered how he had read that one interpretation of quantum mechanics, called the Copenhagen interpretation, proposed that the act of observation was what made reality real. Until a quantum system was observed, it existed in a state of superposition, existing in all possible states at once. But once it was measured, it collapsed into one specific state. This was one of the most fundamental aspects of quantum mechanics. Reality itself seemed to be tied to observation. As Jack sat there, processing all of this, he thought about how deeply this concept challenged everything he had ever learned. In the classical world, things were definite. A coin was either heads or tails, and an object was either here or there. But in the quantum world, things were neither here nor there, neither alive nor dead, until someone looked at them. This wasn't just an abstract idea. It was something that had been tested in labs and verified through countless experiments. The implications of this were profound. If reality itself could be influenced by observation, what did that mean for the way we understood the universe? Could our perception of reality shape what actually happened? Could our observation of the world change the very fabric of existence? Jack closed his eyes, feeling the weight of these questions. The universe wasn't just a place of certainty, of fixed positions and solid realities. It was a place of possibilities, a place where things could exist in multiple forms at once, waiting for us to decide which one would become real. As the stars glittered above, Jack felt both humbled and exhilarated by the mysteries of the quantum world. He realized that understanding quantum mechanics wasn't just about learning formulas and equations. It was about grappling with the very nature of reality itself, a reality that was both more mysterious and more beautiful than he had ever imagined. As Jack sat quietly on the park bench, the weight of all he had learned in recent days hung heavily on his mind. Quantum physics had taken him on a journey through some of the strangest and most mind-bending concepts he could ever have imagined. He had learned about superposition, where a particle could exist in multiple states at once, and how the act of measurement itself could determine reality. But there was one idea, one concept, that had been gnawing at him for a while now. It was the idea of quantum entanglement, a phenomenon that seemed to defy all logic and understanding. Quantum entanglement was a strange and mysterious effect that occurred when two particles became linked together in such a way that their states were directly connected, no matter how far apart they were. This connection was so strong that if something happened to one particle, the other particle would immediately respond, even if they were light years apart. Jack remembered reading about it in one of his books on quantum mechanics. It was an idea that seemed to belong in the realm of magic rather than science. How could two particles separated by vast distances somehow know what was happening to each other? It didn't make sense, not in the world Jack knew. And yet, experiments had shown that it was true. Particles could become entangled, and their behaviors were mysteriously connected, no matter the distance between them. To understand this better, Jack recalled the famous thought experiment of Einstein, Podolsky, and Rosen, known as the EPR paradox. In 1935, these physicists published a paper that challenged the foundations of quantum mechanics. They proposed a scenario in which two particles were created at the same point and then separated. According to quantum mechanics, the particles would be in a state of superposition, where they could have multiple properties at once. Their spins, positions, or energies, for example, were all uncertain. But once a measurement was made on one particle, the state of the other particle would instantly be determined, no matter how far apart the two were. Einstein famously called this spooky action at a distance. He couldn't accept the idea that two particles, once separated, could instantly affect each other. It seemed to violate the principle of locality, the idea that objects are only influenced by their immediate surroundings and not by things that are far away. And yet experiments had confirmed that this spooky action was real. The particles were indeed connected in ways that couldn't be explained by any of the classical ideas Jack had grown up with. Jack leaned forward, his mind spinning. How could two particles, separated by vast distances, share information so instantaneously? It was like magic. Imagine having two dice, each in a different room, 1,000 miles apart. If you rolled one die and it landed on a 6, the other die would instantly land on a 6 as well, no matter how far away it was. It was as if they were communicating faster than the speed of light. And yet, this was the reality of quantum entanglement. He thought about an experiment he had read about, one of the most famous demonstrations of quantum entanglement, the Bell test experiments. In the 1960s, physicist John Bell proposed a test to determine whether quantum mechanics truly allowed for this strange, non-local connection between particles. The results of these experiments showed that entangled particles did indeed behave in a way that could not be explained by classical physics. They violated the local realism that Einstein had believed in and demonstrated that quantum mechanics allowed for connections that seemed impossible in the classical world. Jack was amazed. The particles were behaving like they were connected, like they could feel each other's presence, even though they were far apart. And what's more, the faster they were separated, the more pronounced the entanglement seemed to be. The distance didn't weaken their connection. It strengthened it. The universe was clearly not behaving in the way Jack had always thought. There was something deeply strange going on at the most fundamental level. He thought about the implications of quantum entanglement. If particles could be so deeply linked to one another, could it mean that everything in the universe was connected in ways we couldn't yet understand? Could this explain some of the mysteries of the universe, like gravity or even consciousness itself? Jack felt a sense of wonder growing inside him. This wasn't just a scientific discovery, it was a glimpse into a world of profound interconnectedness, a world where everything was, in some sense, linked together by invisible threads. To illustrate just how bizarre quantum entanglement could be, Jack thought back to a demonstration he had seen in one of his textbooks. It was about quantum teleportation, a process that, at least in theory, allowed for the transfer of information between two particles that were entangled. In a quantum teleportation experiment, one particle's state could be transferred to another particle, even if they were separated by large distances. The key thing was that no physical information was sent through space. Instead, the information about the particle was shared instantaneously through the entanglement, effectively teleporting the state of the particle from one location to another. Jack marveled at this. In classical physics, the idea of teleportation seemed like pure science fiction, but in the quantum world, it was a real possibility. Particles could be in two places at once, and through entanglement, they could share information faster than light could travel. It was a concept that was so far beyond everyday experience that it seemed magical. And yet, this wasn't just theoretical. It had been demonstrated in laboratories. In 1993, physicists were able to successfully teleport the quantum state of a photon from one location to another. The particle didn't physically travel through space, but its state, its information, was transferred instantaneously through the entanglement between two particles. Jack felt both awe and confusion. It was hard to wrap his mind around these ideas. The universe, at its deepest level, seemed to be a place where normal rules didn't apply. Things could be connected across vast distances, and information could be transferred instantaneously. It was a universe full of hidden connections and mysteries, where everything seemed to be part of a grand, intricate web that we could barely understand. Jack took a deep breath and let it out slowly. He realized that, in some ways, the world he thought he knew The world of predictable, classical physics was only the surface of a much deeper and more complex reality. Below the surface, at the quantum level, everything was interconnected, everything was entangled, and everything was much stranger than he had ever imagined. And yet, as Jack sat there, contemplating the strangeness of the quantum world, he couldn't help but feel a sense of wonder. There was magic in the way everything was connected, in the way the universe seemed to play with the boundaries of possibility. The universe wasn't a cold, mechanical place. It was alive with mysteries, with entanglement, with hidden connections that we were just beginning to understand. The magic of quantum entanglement, Jack realized, wasn't just in the science of it. It was in the sense that everything in the universe was somehow woven together in ways that defied explanation. The more he learned, the more he realized how little he actually understood. But that was the beauty of it. The universe, at its deepest level, was a place of endless wonder, and the more Jack explored, the more questions arose, and with each question, the world became more and more magical. The evening had fallen into a deep silence. Jack sat back on the park bench, his thoughts swirling around all the strange and fascinating ideas he had encountered in his journey into the world of quantum physics. Light, superposition, entanglement. Each one of these concepts had shattered his understanding of reality and shown him a universe more mysterious and interconnected than he could have ever imagined. But tonight, his thoughts turned towards something that felt both exciting and daunting: the future. Specifically, he was thinking about quantum computers and how they might one day change everything. The implications of quantum computing were so vast, so far-reaching, that it felt like a glimpse into the future of science, technology, and even human society. Jack remembered the first time he had heard about quantum computers. He was sitting in a cafe with a friend who worked in tech, and they had been talking about the future of artificial intelligence. "You know," his friend had said casually, "the next big breakthrough in computing is going to come from quantum mechanics. We're talking about machines that can process information in ways we can't even imagine right now." Jack had been intrigued, but also a little confused. How could a computer, a machine that processes information, work in the quantum world, where everything seemed so uncertain and strange? To understand quantum computers, Jack knew he needed to first think about how traditional computers worked. In the world of classical computing, computers process information using bits. A bit is the smallest unit of data, and it can exist in one of two states, either 0 or 1. These zeros and ones are the building blocks of all the information we process every day. Whether it's browsing the internet, running software, or playing a video game, it's all done through billions of bits working together to represent data in a way that the computer can understand. But here's the catch: no matter how powerful a classical computer is, it is still limited by its reliance on bits, which can only represent one state at a time. A bit is either a 0 or a 1. And while modern computers have become incredibly powerful, they still face limits on how quickly they can process complex information. There are problems in science, cryptography, and optimization that are simply too difficult for even the fastest classical computers to solve in a reasonable amount of time. This was where quantum computers came in. Instead of using bits, quantum computers used quantum bits or qubits. The key difference between a qubit and a classical bit was something Jack had learned about during his exploration of quantum physics: superposition. While a classical bit could be either 0 or 1, a qubit could be both 0 and 1 at the same time, thanks to the principle of superposition. It was like flipping a coin and having it be both heads and tails while it was spinning, only settling on one side when you observed it. Jack was amazed by this idea. It was as if quantum computers could handle multiple possibilities simultaneously. This ability to exist in multiple states at once meant that quantum computers had the potential to process vast amounts of information in parallel, far beyond the capabilities of classical computers. To illustrate this further, Jack remembered something he had read about how a quantum computer might solve problems. Imagine trying to solve a puzzle with many possible solutions. For example, finding the shortest route to travel through multiple cities. A classical computer would go through each possibility one by one, checking every possible route until it found the best one. A quantum computer, on the other hand, could process all of those possibilities at once, thanks to superposition. It could explore all the possible solutions simultaneously and find the optimal one much more efficiently. This ability to handle vast amounts of data simultaneously was what made quantum computers so powerful. But there was another key feature of quantum computers that set them apart: entanglement. Remember how entanglement allowed two particles to instantly communicate with each other, no matter how far apart they were? Quantum computers could use entanglement to link qubits together in a way that classical bits could never be linked. This allowed quantum computers to perform complex calculations and simulations much more efficiently. Jack found this incredibly exciting. Quantum computers weren't just faster versions of classical computers. They were fundamentally different. They were capable of solving problems that were practically impossible for classical computers to handle. This included things like simulating the behavior of molecules for drug discovery, optimizing complex systems like supply chains, and even cracking codes that would take classical computers thousands of years to break. But as Jack thought about this more, he also realized that quantum computing wasn't without its challenges. There were significant obstacles to overcome before quantum computers could become practical and widely accessible. One of the biggest challenges was decoherence. In the quantum world, particles are extremely sensitive to their environment. Even the slightest disturbance, like a change in temperature or electromagnetic radiation, could cause the quantum system to lose its coherence, meaning that it would no longer behave in a quantum way. This made it difficult to maintain qubits in their superposition state long enough to perform meaningful computations. To solve this problem, researchers were working on building more stable quantum systems. Some were experimenting with superconducting qubits, which could be kept at extremely low temperatures to reduce the effects of decoherence. Others were exploring topological qubits, which are less sensitive to environmental noise and could, in theory, maintain their quantum state for longer periods of time. Despite these challenges, progress in quantum computing was accelerating. Companies like Google, IBM, and Microsoft were investing heavily in quantum research, and several startups were emerging with innovative approaches to building quantum computers. In 2019, Google made a major breakthrough, claiming to have achieved quantum supremacy, a moment when a quantum computer performs a calculation that would be impossible for a classical computer to do in any reasonable amount of time. Although this milestone was controversial and the problem solved wasn't of major practical use, it was a significant step toward proving that quantum computers could outperform classical computers. Jack felt a sense of awe as he thought about the future. Quantum computing had the potential to revolutionize nearly every field. In cryptography, quantum computers could break encryption methods that were considered unbreakable today, forcing the development of new quantum-resistant encryption methods. In medicine, quantum simulations could help scientists understand complex biological systems at the molecular level, leading to the discovery of new drugs and treatments. In artificial intelligence, quantum computers could accelerate machine learning algorithms, making AI smarter and faster. Jack imagined a future where quantum computers were an integral part of everyday life. They might be used to solve problems that were once thought insurmountable, from curing diseases to predicting the weather with unprecedented accuracy. They might even help unlock the mysteries of the universe itself, enabling scientists to simulate complex systems like black holes or quantum field theories in ways that were never before possible. But, as with any new technology, there were also potential dangers. If quantum computers became widely available, they could challenge the security of current systems, potentially exposing sensitive data. The power to break encryption and solve complex problems could also be misused in the wrong hands, leading to new kinds of cyber threats. Jack realized that, like any powerful tool, quantum computers would require careful management and ethical consideration as they became more advanced. As the stars twinkled above him, Jack thought about how much the world had changed in just a few decades. The discovery of quantum mechanics had already transformed our understanding of reality, and now, with quantum computing on the horizon, humanity was poised to enter a new era of discovery and innovation. It was an exciting time to be alive, but also a time of great responsibility. Jack felt a sense of wonder and possibility. The future was unfolding before him, and the tools to unlock its mysteries were already in development. Quantum computing was just one of many frontiers that humanity would explore in the coming years. And though there were still many challenges ahead, Jack couldn't help but feel optimistic. The universe was vast, mysterious, and full of potential. And with quantum computers, we might just be able to understand it a little better. As Jack sat back on the park bench, gazing up at the vast night sky, his mind began to wander. The mysteries of quantum physics, superposition, entanglement, the duality of light, and the strange workings of quantum computers seemed so far removed from his everyday life. Yet, something inside him told him that all of this, however distant it seemed, was more connected to his own existence than he had ever realized. The more he thought about it, the more he could sense the thread that tied everything together. From the smallest particles to the largest structures in the universe, everything seemed to be part of a grand, interconnected system. Jack's thoughts returned to the beginning of his journey into quantum physics. It had started with a simple curiosity about the world around him, a desire to understand how the universe worked. He had learned about the everyday physics of gravity, force, and motion. He had explored the strange and paradoxical world of quantum mechanics, where particles could be in multiple states at once and seem to communicate faster than the speed of light. He had seen how the principles of quantum mechanics were pushing the boundaries of technology from quantum computers to quantum communication. But what did all of this have to do with him, with you, with all of us? It occurred to Jack that the very essence of quantum physics was about interconnectedness, the idea that everything in the universe at its deepest level is connected in ways we can barely comprehend. At the quantum scale, particles that were once part of the same system remained linked regardless of the distances that separated them. The strange phenomenon of entanglement was just one example of how the universe seemed to defy the rules of classical physics, showing that things could influence each other even when they were far apart. And this wasn't just a theoretical concept. It was a real, observable phenomenon. Jack thought about how all of this applied to him. As he had learned more about quantum mechanics, he realized that at the most fundamental level, the very fabric of the universe, the particles, the forces, the energy, was the same as the matter that made up his own body. The atoms that formed his skin, his muscles, and even his thoughts were composed of particles that followed the same rules of quantum mechanics. The very particles that made up the stars, the planets, the trees, and the animals were also governed by these same strange laws. And, in a way, Jack, like everything else, was a part of that vast interconnected web. This connection wasn't just metaphorical, it was real. The atoms that made up Jack's body had once been part of other stars, planets, and galaxies. When stars exploded in supernovae, they scattered the building blocks of life, the elements like carbon, oxygen, and nitrogen, across the universe. Over billions of years, these elements came together to form the very atoms that made up Earth, and eventually, life. The particles that formed his body had, in a sense, traveled across space and time, passing through countless stars and galaxies before coming together to form who he was. Jack smiled at the thought. He was connected to everything, the stars, the trees, the oceans, and every other living thing. But this connection wasn't just a poetic idea. It was grounded in the physical reality of the universe. The same quantum laws that governed the behavior of particles at the smallest scales were at play in the world around him, shaping the very nature of existence. The weird and wonderful phenomena of quantum mechanics, superposition, entanglement, and the duality of light weren't just theoretical concepts confined to laboratories or distant galaxies. They were part of his own experience, influencing the world he lived in and the body he inhabited. Jack thought about how the concept of quantum entanglement might apply to his own life. Entanglement meant that particles could be connected, no matter the distance between them. Could this idea of interconnectedness extend beyond the realm of physics? Could it suggest that everything in the universe, every person, every animal, every plant, was linked together in some deeper, more meaningful way? Jack wondered if there was something more to this than just a scientific principle. Could it be that we too were entangled with each other, bound by invisible forces that transcended space and time? It was a thought that made him pause. Perhaps, he thought, the quantum world wasn't just about the behavior of particles. Maybe It was a way of understanding our place in the universe, a reminder that we are all part of something much larger than ourselves. In the same way that particles could be connected across vast distances, maybe the actions and thoughts of individuals were somehow interconnected, affecting each other in ways we couldn't fully understand. This line of thinking brought Jack back to another idea he had encountered in his exploration of quantum mechanics, the concept of non-locality. Non-locality was the idea that things could be connected in ways that didn't depend on their physical proximity. The phenomenon of quantum entanglement was an example of this. Two particles could be instantaneously connected, even if they were on opposite sides of the universe. It was as if space and time, the very dimensions that separated us, were not as solid and unbreakable as we had always thought. Jack felt a sense of awe at the implications of this. What if, at the most fundamental level, the universe wasn't divided into separate, isolated parts? What if everything was interconnected, not just through physical forces, but through some deeper, invisible bond that transcended the limits of space and time? He thought about how our lives were intertwined with the lives of others, how the choices we made affected the world around us, how our actions rippled outward, touching people and places we may never even see. In a way, this was a reflection of the quantum world, where everything was connected, and where the behavior of one particle could influence the state of another, no matter how far apart they were. Jack thought about this for a while. He realized that understanding quantum mechanics didn't just change the way we looked at the universe. It also changed the way we looked at ourselves. If the universe was a web of interconnectedness, where everything affected everything else, then maybe our lives were not as isolated and disconnected as we often felt. Maybe our actions mattered more than we realized, and the connections we formed with others were part of a much larger cosmic network. The idea of quantum entanglement didn't just challenge our understanding of particles. It also challenged our understanding of how we, as individuals, fit into the world. It suggested that our lives were part of a much larger interconnected whole. The choices we made, the relationships we formed, and the actions we took were all part of a vast, ever-expanding web of influence. Just as particles could be entangled and affect each other across vast distances, so too could our lives be connected in ways that went beyond our immediate experience. Jack felt a sense of peace and connection. He was part of this vast universe, a universe governed by the strange and beautiful rules of quantum physics. He wasn't separate from it, but rather an integral part of it. The quantum world wasn't just a distant, abstract concept. It was part of him. And in the same way, everything around him, the trees, the stars, the people, was part of him as well. We were all connected, whether we could see it or not. As the stars twinkled above him, Jack smiled. The universe was not just a collection of isolated, independent parts. It was a vast, intricate, and interconnected whole. And even though we couldn't always see it, we were all part of it. Everything was linked, not just by the forces of gravity or light, but by something deeper, something quantum, a force that transcended time, space, and matter itself. Jack took a deep breath, feeling a sense of wonder wash over him. The mysteries of the quantum world were vast, and there was still so much to learn. But now, more than ever, he felt connected to the universe, not as an observer standing outside, but as a participant in the grand, unfolding story of existence. And with that thought, Jack stood up, feeling the weight of the universe in the most beautiful and humbling way. The world around him, the world of particles, light, and energy, was not separate from him. It was him. And he, like everything else, was part of the eternal dance of the cosmos. The night air had grown even cooler as Jack stood, stretching his arms toward the sky, his mind still buzzing with the mysteries of the universe. He had come a long way in his journey through the strange world of quantum physics. What had started as simple curiosity about the nature of light had led him to explore the depths of reality itself. From superposition to entanglement, from quantum computers to the profound interconnection of everything in the universe, Jack had learned that the world was not as simple as it seemed, but somehow it was more beautiful because of it. As he stood there, gazing at the stars that now dotted the night sky, Jack felt a deep sense of awe. He realized that despite the strangeness and complexity of what he had learned, the mysteries of the universe were not something to fear. They were something to embrace. They were not obstacles to understanding, but invitations, invitations to explore, to ask, and to discover more. The universe, at its deepest level, was not just a mechanical system of predictable forces. It was a place of wonder and possibility, a place where the boundaries between the possible and the impossible were often blurred. The more Jack had learned, the more he understood that the universe was alive with hidden connections, with magic that could only be glimpsed through the lens of quantum physics. But even as he marveled at the intricacies of quantum mechanics, Jack understood that the world around him was still the same world he had always known. The trees, the stars, the people, all of them were still there, still governed by the same forces that had always existed. And yet, in light of everything he had learned, they seemed different now. They seemed more interconnected, more vibrant, as though the universe itself was a living, breathing thing, one that Jack was a part of. He thought about how all of these ideas, superposition, entanglement, the strange behavior of light, were not just concepts to be studied in a lab. They were part of the world he lived in, part of the reality he experienced every day. The atoms in his body, the stars in the sky, the trees swaying in the breeze, all of them were connected in ways that went beyond what he could see. The universe was not a collection of separate, isolated things. It was a single, unified whole, a cosmic dance that had been going on since the beginning of time. Jack closed his eyes for a moment, letting the quiet beauty of the night wash over him. He realized that just as quantum particles could be in multiple states at once, so too could the world around him be filled with multiple layers of meaning. The universe wasn't just a place of physical laws and equations. It was a place of mystery and wonder, where every question led to more questions and every answer opened up new possibilities. With a final, deep breath, Jack stood up and started walking home, the night around him feeling like a world of infinite possibilities. He didn't have all the answers, and perhaps he never would. But that didn't matter. What mattered was the journey of discovery, of exploration, and of learning how deeply connected everything was. And as he walked under the canopy of stars, he realized that the true beauty of the universe lay not in the answers we found, but in the questions we asked, the mysteries of quantum physics, the strange behavior of particles, the vast interconnected web of existence, all of it was an invitation to explore, to learn, and to experience the world with wonder. As Jack reached his front door, he paused for a moment, taking one last look at the night sky. He felt a deep sense of peace. The universe was vast, and there was still so much to learn. But for tonight, he was content. He had learned enough to know that the world was far more mysterious and beautiful than he had ever imagined. Jack smiled to himself, knowing that tomorrow would bring new questions, new discoveries, and new wonders. But for now, it was time to rest. He stepped inside, closed the door behind him, and went to bed. As he lay in the quiet darkness, his mind drifted not to the complexities of quantum physics, but to the simple joy of knowing that he was part of something much greater. He wasn't just an observer of the universe, he was part of it, woven into its fabric, connected by forces that were still beyond his full understanding. And with that thought, Jack closed his eyes. Feeling the warmth of the world around him, the mysteries of the universe could wait for another day. For now, he was content, knowing that the beauty of life lay in the journey itself, in the questions, the discoveries, and the wonder of it all. So, as you close your eyes tonight, remember that you, too, are part of this great cosmic dance. The world may seem vast and full of mysteries, but you are connected to it just as it is connected to you. And just like Jack, the journey of discovery is never truly over. There are always new questions, new wonders, and new mysteries waiting to be explored. Sleep well and dream of the universe, vast, mysterious, and full of possibilities. Good night.